So my name is Anand Ranganathan, and today I'll be talking about a new way for people to explore data that we call natural language and conversational analysis on interfaces. So the core focus is to make it easy for non-technical business users or even the general public to ask questions on databases without having to know SQL or Python or other BI tools. So we want to completely democratize data, make it easy. Anybody who knows English should know how to get to data. That's our goal. So in today's talk, I'll talk about our vision for this new paradigm for exploring data and how we've designed our product around this. So today, how do people consume data? It's mostly through charts and dashboards. And there have been a couple of talks before on possible death of dashboards, which I won't go into detail. But this is the way most people look at data. There's teams in enterprise that produce charts and dashboards, and you see charts and dashboards every day. So even for instance, with COVID, there was like a massive explosion of charts being produced about all aspects of COVID. But dashboards are limited. So there are several disadvantages of dashboards. So firstly, the dashboard offers a snapshot of a piece of data in time. You often can't drill down in different ways unless those drill downs are explicitly configured. And even then, it's very limited in what you can do. You often don't know how the data for the dashboard was produced. So you don't know what the source data was, what transformations might have happened in the dashboard creator or report creator to produce the final charts. You also can't ask a slightly different question. So each chart answers one question. But if you want to ask the question in a different way, explore some different aspects of the data, the dashboard or chart doesn't allow you to do that. And one of the biggest issues, I think, with dashboards is that I almost think of, and this has been talked about in many other sessions, is that data analysis is still an artisanal kind of endeavor. So each dashboard creator or each report creator is an artist that's looking at the raw data and figuring out what's most interesting and presenting it in some possibly biased manner, right? So it's easy to cherry pick stats, cherry pick some portion of data to create the right story. And hence, charts and dashboards can often be quite misleading. So we realize all these problems with dashboards, and we think there has to be a better way, right? And that's where our approach of conversational and natural language interfaces to data comes in. So what is conversational analytics, or at least our definition of it, and even Gartner's definition of it now? The ability to allow users to ask questions of data in either text or voice and get back a natural language and or visual analysis of the results in a manner that's relevant to the user. And to have all this happen in a conversational setting, where it's not just one query, but you can keep asking more queries in a conversational manner. So for this talk, I'm going to focus on structured data specifically. So asking questions on structured data, which is typically presented in some relational format, either in SQL or SQL-like databases, in Excel sheets, and other tabular formats. So this is our product. I won't spend too much time on the marketing or sales, but this is one slide on the product itself. So we have a bot called Cubo. Hopefully at some point it'll be as popular as Alexa and Siri and other such bots. But we have a bot called Cubo, which allows people to have natural language conversations with their data, especially within collaboration platforms. So Cubo acts as an AI-powered data analyst. So at some point in the future, like all jobs, even data analysis will probably be replaced by AI. Maybe we're taking the first steps over there. But Cubo allows people to have natural language conversations with their data within collaboration platforms. And by collaboration platforms, I mean platforms like Microsoft Teams, Slack, Zoom, and others. So within Cubo, you can ask questions. You can ask descriptive questions like what happened last month, and how many policies expiring in a given month, why were there fewer customer acquisitions. You can ask diagnostic questions as well, like why did sales drop. You can also ask predictive questions. I'll show you some examples of all those kinds of questions. Behind the scenes, the main part of Cubo is the ability to convert natural language to SQL and or Python-based machine learning models. Send those queries to a backend database, get back the answers, if necessary, apply more analytical processing on the results, and present the results back to end users. So Cubo can connect to different enterprise databases. Users can converse with Cubo to ask questions, and then they can collaborate with one another because it's part of Teams and soon Slack as well, so as to explore data jointly. So the way this is set up is that Cubo sits in between one or more users and variety of data sets. So today we support two main interfaces, a web browser interface as well as a Microsoft Teams interface. And we support about 20 different kinds of backend database connectors, all the popular databases, Snowflake, Redshift, even Excel sheets, as well as some applications like Salesforce, Google Analytics, and others. So depending on the question users ask, Cubo can connect to one or more of these enterprise databases, either internal, sometimes external as well. Get back the answers and shows the answers to the end users. So I spent a majority of the talk going through kind of a demo of the platform, but focusing on some of the key challenges and some of our initial approaches to tackle this issue. So for the purpose of the demo, I'm going to actually focus on a data set that I set up last week on 311 data from Austin. Anybody from Austin here? Okay, so might be relevant. So some of these might be relevant to you. So 311 data. So 311 data, as you know, is so whenever any citizen of the city of Austin or any city really has any kind of complaint, like there's potholes, there's a loose dog. Loose dogs seems to be especially popular in Austin. They will raise a 311 request. So Austin has been doing a good job of collecting this data and making it public. So there is a site in the Austin data.austinintexas.gov where this data is being updated almost on a daily basis. So I took a snapshot of this data last week and put it in Snowflake. So there are about 1.2 million rows in this data. There's a variety of different columns. There's data about the date or when the request is created, the status of request, what kind of request it was, when it was closed, and so many things, and lots of other pieces of information. This is like a fairly typical data set, but the goal is now, can we start asking questions in English on this data and uncover interesting insights? So the way this is set up, at least for this demo, is I put this in Snowflake, and this is our web interface. So the way this is set up is you want this to be collaborative. So each time somebody logs in over here, they see, what are people asking, how many people are asking different kinds of questions, what's the activity, and then have a very conversational approach for people to start asking questions. So there's some elements of Slack and Microsoft Teams even in this interface. So we have a notion of channels, where a channel can either be a one-on-one conversation that you have with a bot or a group chat where a bunch of people can be chatting with each other as well as the bot to uncover interesting insights. So there's some sample questions people have asked. So now I'm starting a new thread over here. So one of the key principles that we decided to embark on is that all data analysis should be almost present as transcripts. So very often what happens in terms of reproducibility data analysis, you might ask some questions a few days back or a few weeks back, got some answer, and unless you manually stored that answer somewhere, that's lost. Right? So one of the purposes of making this conversational is that we want to save transcripts of all your questions that you ask on data so that later on you can go back and see what did you ask and what else did somebody else comment on this piece of data. So we have this notion of named threads where you can see different threads on actually different. So I have this policy now wherever I present, I create a demo on that data. So a couple of weeks back, this was on Hartford. So now it's in Austin. But you start asking questions. So my first question is show me some data about sample incidents. So I just asked Austin 311 incidents, and this is what comes back. This is showing the different, the city, the created date, method received, service description. In this case, the bot describes how best to present it. It's decided to show it as a table here because there are lots of columns. And in other cases, it might show it as a bar graph or a line chart or a pie chart or something else. So let's take the next question. So now this is more descriptive. So I just asked, what are the service descriptions, right? So I'm going to explore the data a little bit, ask some more descriptive questions. And now these are different service descriptions available in this data set. So again, you get a list of all the kinds of issues. So issues like compost, brush and bulk, data animal collection, and a whole bunch of others. Next question is, what are the ways these methods were received, whether it came by email, by phone, 311. So there's a variety of descriptive questions where behind the scenes, what happens is that each of these questions gets translated into a SQL query that goes to the Snowflake database, gets back the answer. once answer comes back, we figure out how best to present it. So we asked what are the zip codes, and now these are the zip codes where we have these incidents coming in place. So that's some basic, some questions that just help us understand a bit more about what data is coming over here. I can also explore the data in different ways. So we have a chat interface. You can ask exploration questions. I asked just now, what is the total number of incidents? In this case, 1.2 million incidents. Keep drilling into data. What are the different attributes or different metrics that have been defined? So let's ask a slightly more complex question over here, right? So I'm asking number of graffiti incidents in 78701 last month, right? So this is a slightly more complex question where there are actually a couple of different filters. One graffiti, 78701 has to be interpreted now correctly. In this case, a zip code. It's a time filter. So now the system's going to figure this out. And one of the key ideas here is that we want to present an understanding of the question back to the user. So when I asked number of graffiti incidents in 7801 last month, it's come back with an answer. The answer is 13. But beyond that, it's said a few other things that added context to the answer. Right? So one of the things it said is that I interpreted the term graffiti as a filter where service description contains graffiti. So that's one way of interpreting the term graffiti, which is important from a semantic point of view. And I'll tell you why it's interpreted this way in this case. It also decided that the 70701 is a zip code, and last month is last month. So in this case, last month specifically interpreted as February 2022. So one of the key ideas over here, like the previous talk, where it's a human and a machine interacting. Just because you ask a question, got back an answer, the machine is not just saying the answer, but also giving information on how it interpreted the question. So it's clear exactly what are the different elements that went in, what are the different filters or groupings or sortings that went in to create the answer. Right, so digging a bit more, so in this case, graffiti incidents is interpreted that way, and just remember that because I'll show you how the semantic layers is defined. So this is the actual SQL query that got generated behind the scenes. If you wanted to know exactly if you didn't trust the answer, if you wanted to create a SQL query yourself and see which tables it's hitting, what are the filter clauses, what's the where condition, and so on. This is the SQL query, so allows transparency into the system. Let's see, keep going on. So one of the key things here is the semantic layer, right? So let's see what's the next one. Right. So let's see why in this case it decided to take the semantics. We decided to interpret graffiti as all services that contain the term graffiti. So in this data set, as it happens, there is some uncleanness. So, and this is true for most data sets, that there are actually, at different points in time in the city of Austin, over the past 12 years, this is something I found, there were two different ways in which the term, for describing graffiti incidents. So between 2014 and 18 or so, it is called graffiti abatement incidents, and after that started being called public health graffiti abatement, right? And that's something you see in data often. The terms used might change and so on. So, but when somebody asks graffiti, it could mean either of these. So one of the key things we do is to have a semantic layer where we can create a mapping or definition that when somebody says graffiti, it could mean either of these. So anything that contains the term graffiti is a graffiti incident, right? So that helps us in overcoming the challenge of possibly unclean data where the terminology might not be well defined, might be changing over time, and still allow people to ask questions in a fairly reliable manner to the system. So these two kinds of graffiti incidents, and yeah. So let's zoom in a bit. So let's ask a few more kinds of questions. So there's top 5 service descriptions in order the number of days, average days open. So one of the slightly more complex question where I'm ordering the different incident types based on what's the average time they were left open. And in this case, some of the biggest ones were on basic needs appointment or dumpsters, residential rebates, and so on. So I don't know if any of these resonates with the folks in Austin over here. But the other thing that we do is to generate a natural language narrative as well. So there's beyond understanding the question, there's also a narrative that describes what information came back and some interesting interesting insights in that data. I can ask 10 trend questions like the number of incidents monthly. And the interesting thing I saw over here is that there's actually a nice seasonality where more incidents are reported between, say, March and June, and less incidents after that, maybe because of all the events in Austin that period of time. But also says, for instance, that May 2021 had the most number of complaints reported. So as soon as you find something interesting, there's a model that we borrowed from Pinterest where I can pin interesting insights to a board and see and then keep it for posterity, and also share it more easily. So essentially, you can very quickly create interesting dashboards on the data. So now, in this case, we saw this. Let's say we see this big spike. This happened to be, I think, in March 2021. There's a big spike in incidents, right? So one of the kinds of questions we support is why questions. So I could ask a question like, why is the number of incidents in March 2021 higher than February 2021? Because that's where I want to compare those 2 months. In this case, it actually builds a model behind the scenes on what are the factors that drive incidents, what are different values, different dimensions that could explain what changed between those 2 months. And this happens on the fly. So here, this is a slightly bigger NLG that talks about the biggest changes or the biggest factors that could explain this. So for instance, over here, it's come back and said that the number of incidents rose by 61%. The top reason is that there was a big increase in number of incidents of type missed yard trimmings. So that jumped by 798%, and that it says is the biggest reason that contributed to why so many more incidents in March compared to February. And then some other incidents as well. Certain zip codes like 78704, 78701 had lots more incidents, micro-mobility incidents, and others. So this is an example of a why question. And then we can dig into this a bit more. So this is where the conversational aspect comes in, because it's very rare that the first question you ask is going to get you the insight that you are looking for. So now let me dig deeper. What happened in missed yard trimmings, right? So let me ask a question on number of missed yard trimmings monthly. So now get a line chart or a trend line on missed yard charts. And then we see this big spike, right? In March 2021, there were so many more incidents of missed yard trimmings. So we think data analysis is iterative, right? You have to keep asking more questions, you keep digging into data. Today, though, with just plain dashboards or reports, that kind of thing is not possible. Another feature of a conversation system is that it's conversational. So your subsequent questions could be interpreted in the context of previous questions. So my first question in that particular segment was number of missed yard trimmings monthly, and then I said by zip code. So depending on the question, one of the models that we built under the scenes is predicting if any given question is a new line of analysis or is a continuation of a previous line of analysis. So in this case, it's figured out, okay, it's a continuation of a previous line. So when I said by zip code, it's going to try to show you both by month and by zip code what happened. So here, again, it's given some NLG narrative on which zip codes and which months had the biggest number of missed yard trimmings complaints. And here, look at line chart. It's pretty busy. There are lots of zip codes that this data set covers. So maybe since it's too busy, let me try to filter some more. Let me just say in March 2021. Again, part of the conversational, just asking questions, going to interpret in the context of previous questions. So let's go back, and in this case, let's look at it in a map. So which zip codes in March 2021 had how many missed yard trimming incidents? And then we see like two big spikes in a couple of zip codes. I think 78737 and 78759. I don't know if any of you live in those zip codes. Okay. So this is quickly figuring out some interesting insights from the data through natural language queries. Let's see. So the last part I'll show is around analytics. So one of the kinds of analysis that we have in the product is association rules, and many of you are very familiar with that. But the idea is to find out what are interesting associations between different variables in the data set. So I can just ask, what are top 20 associations, right? And then This actually, there's a batch process which calculates, which mines the rules and then presents them. But this happens on the fly, right? So, and again, the part of the idea here is that we want to completely automate data science almost. So even training of model, training of association rules model, training of time series forecasting models, and most, we would say most typical classical machine learning models, we think can be automated over time. So here, let's come back with the top association. So for instance, the top association here is that zip code 78702 that came in through mass entry had a very high association with graffiti abatement. Then 78701 had lots of issues around parking machine issues. So those associations are not discovered automatically, presented to the user. And a data scientist could then take this and improve the model if they want to, but this gives you a first cut model on the fly, configured fairly in automated fashion and present to the users. And now the user can go and at least start exploring these, maybe explore more, for instance, on what happened with parking machine issues in 78701, and which months were worse, or which kinds of users reported them, and so on. So that's a quick overview of our vision of conversational analytics. We still have ways to go to make it completely usable, but that's where we want to take this to make eventually data sciences AI powered. This is showing the NLG behind it, so how it's explaining some of these concepts. So for instance, saying that there's a strong association between 78702 and graffiti. I don't know if anybody's 7702 in the audience. And if you can validate the graffiti issue, that might be prevalent there. And then giving stats as well. So it's also talking about things like confidence and lift and other metrics to say, why is this an important or interesting aspect. So one of the key things that makes this work is a semantic layer. And there's been lots of talks again on semantic layers, metric layers around data, right? And for us, there's a very heavy dependence for us on a semantic layer. And we're happy to see progress in things like DBT and transform others but I think it's still very, barely scratching the surface on I think what's needed to have true semantics. Not just defining metrics, but almost defining what's the meaning of certain concepts, right? And how should certain terms be actually interpreted. So here's the example that I showed before. So once we realized that, for instance, graffiti had this interesting characteristic that there were two different terms for almost the same thing at different points in time in the data set, we had to create a semantic model saying that whenever somebody asks anything about graffiti, look for these two concepts. Or in this case, define it as if a graffiti is anything that any service description that contains the word graffiti in it should be included in when they talk about graffiti. So I'm defining graffiti as service descriptions that contains, in a string manner, the substring graffiti. So that's what we often mean by semantic layer. So other examples are, very often you see data sets where you'll have a gender column, and the gender column is M's and F's, right? And implicitly, we all know that M means male, F means female, but there could be some other weird cases. I've also seen cases where the gender column has zeros and ones, and implicitly somebody somewhere knew 0 meant male, 1 meant female. But those are semantics that we need to capture to allow people to ask questions on data. So when somebody says how many female customers are there, this semantic layer needs to know that, okay, behind the scenes, it needs to have where gender is equal to 0, for instance. So there's a lot of semantic, we put in a lot of effort into figuring out what's the right semantic layer that is needed to capture those implicit semantics of data that can really help improve the accuracy of the NLP. So we have a notion of a thesaurus. We have a notion of our own richer ontology of data types. So beyond the basic data types that you might see in databases, we also define a much more richer ontology, things like locations, things like currency, latitude, longitude, and a whole bunch of other things. That often helps also in name entity recognition in the NLP side. You can also define metrics that way. So metrics are metrics. I think good work is happening with metrics, but you can also define metrics in this system. You can define more new variables. For instance, like days open is a new metric, or a new variable where you find the difference between the days closed and the day open. Here's an example of how we configure the association rules, where if a data scientist, data analyst wants to fine-tune or tailor how some of those models are being trained, you can configure them, say, okay, I'm looking for associations between zip code and method received to service description. And that's the hint you give to the system to help it constrain the space that it's searching for when it's trying to come up with interesting insight and patterns in data. So trying to make even analytics be UI-driven, the UI-driven data science almost. Right? So that's the semantic layer, and I'll talk a bit more about what goes on in the semantic layer, but that's a quick demo of our vision of conversational exploration of data. So let's take that. Let me see how much time. Okay, I'll quickly go through some of the remaining slides. So like 5 minutes more. Oh, yeah. Oh, yeah. Got it. Yep. Thanks. So at a very high level, we have a fairly sophisticated NLP pipeline because it turned to be a fairly challenging task to understand often grammatically incorrect and vaguely expressed natural language queries into converted to SQL at the very end, right? So it's a very simple. There's lots of other pieces that go into it, like spelling correction and tokenization, normalization, and so on. But some of the key things that we had spent a lot of time to figure out how to make good work are things like entity recognition, recognizing that, like segmenting firstly the whole the tokens in this. That number of trips is one concept. Winter 2017 is another concept. Age and gender is another concept. So that's the segmentation, and then figuring out how to interpret them. When you have those kinds of concepts coming in, what could be a kind of query? So in this case, maybe it's an aggregation query with some filters, and then also deciding how to interpret certain things. So Winter 2017 is a general concept, but now it has to be converted to a date range because in SQL it has to be a date range. So coming up with all the right interpretations, going step by step from complete sentences to entities to matching them to a database, and then finally generating a SQL query where the SQL also has to depend on the specific database, and then going to the final, getting the result and presenting it. So in a sense, the way you can almost think of this as like English to French or English to German translation, except that there are probably a million different Frenches because each database has its own French or own German. So we've taken almost a language translation approach with a lot of customizability because every database is unique, right? So, and every database has its own semantics. So for instance, if I asked a question on Austin in that OST 311, Austin means Austin. But if I ask the same question on IMDb database, most likely it's going to talk about Austin Powers. So the term Austin is totally dependent on the data behind the scenes, right? So that's something which we had to spend our time in figuring out how to make it work. So a key challenge that we face is bridging the gap between users and data, and that's where semantic model comes in. Right? So as we've brought the system out and got some customers in and some other pilots, so some of the key challenges we've seen are when presented a system like this, users often don't know what to ask. They don't know how to ask them. There's often ambiguity in how they frame their questions. Most users are not familiar with there's filters and group by. They just ask questions. They would just say customers. Implicitly, they think they mean number of customers, but that's very implicit, right? So that whole ambiguity is an important, it's a big challenge for us. And finally, users may not use terms in the data set. The out of data set issue is pretty challenging, especially. So on the data side as well, there are also different issues, right? So data could be modeled different ways. There are different kinds of schemas, different implicit assumptions on whether it's normalized, de-normalized. What is the meaning of sometimes you have tables that act like join tables for and cross-M relationships. Sometimes you have so there are lots of different patterns of modeling data databases, some good and some bad. And still, we had to, we made the assumption that you can't change the data. The data is as it is, because in many cases that's what it is. But you can add a layer on top of it that will try to make it easier for users to query. There's often lots of hidden semantics. Data might be incomplete and unclean, like the case I showed in the Austin data. And finally, data might be spread across silos. Right? So let me take an example of a deeper example of the semantic model. So this is another data set. This is on city bike share data. So let's say that the physical data model had these kinds of attributes. There's a trips table that had start time, stop time, trip duration, and so on. and the user is asking a question, like what's the number of rides by age group? Right, so there's lots of terms here that's not present in the actual data model. There's nothing called age group in the data model. There's nothing called rides is not there, but there's something called trips. So there's some mapping that needs to happen, and that's the semantics that needs to emerge from the data for users to ask questions. So as an example, some of the semantics that you might want to capture is that, for instance, age range is something that could be extracted or derived from birth year. And there might be a formula to derive age range from birth year. Another semantic that we support is defining not just metrics, but something as we call segments. Because you could ask questions like, what's the average number of trips taken by old customers? What's an old customer? So you've got to define the semantics for what is the meaning of old in this context, and maybe it's based on, again, the birth year. So all those are semantics that slowly we keep adding more and more semantic information to make it easier for the users to ask more questions more naturally. But then now we come up with this process now where the semantics are you can define them through a UI, but they can be versioned, they can be very often checked into a source control system, and then you can keep collaboratively expanding the semantics as time goes on. So the way typically this is set up is that Cubo sits between users and databases. When we first set up the system, it crawls the data. It comes up with an initial semantic model based on our prior knowledge or prior experiences of what data looks like typically. But then a data model or administrator can come in and add more information using that UI I briefly showed. And then those semantics now get used so that whenever a user asks a question, the first thing it does is figure out which data source and database might have the question, might be able to answer the question, convert it to a SQL query, get back the answer, and then present the answer back to the users, like I showed you. So I'll stop here. There's time for some questions. But this is our vision of future of work, future of data, and how people might explore data using conversationals. Thank you.